Okay, so this week we are going to cover basic layout concepts from your construction surveying layout book, chapters 3, 6, 7, and 9. I have another extremely fascinating PowerPoint presentation. One of these days I'll get into PowerPoint a little bit more and actually get into putting more colorful things in there. And the intent is also to just kind of summarize chapters 3, 6, 7, and 9. That would be also reading assignments for this week. So chapter 3 is all about fieldwork practices, talking about safety, measurement principles, tolerances for construction layout, field notes, general instrument care, use and care of hand tools, leveling an instrument, and instrument setups. I will put this PowerPoint presentation on Brightspace. If you actually do want to flip through it, just as a quick reference to what each chapter has and where, like chapter and page they begin. With safety is important. A lot of companies do profess a lot of safety, have a lot of safety policies in place. Safety does need to be taken seriously. I know a lot of people still kind of hem-haw, say, whatever, I need to get the job done. However, you gotta have a responsible attitude, and you gotta take control of safety for yourself and for your coworkers around you. There's also a section about personal protective equipment, PPE. That includes things like your high-vis clothing, your vest, gloves, safety glasses, hard hats, steel-toe boots, things to that nature. If you get into construction staking, those PPE is kind of mandatory for a lot of construction sites. And again, that is for your protection. Companies are required to provide PPE for you, as far as like the hard hats, gloves, safety vests, glasses. A lot of companies might provide you a stipend or something like that to go buy boots. And it's a couple different things. You know, they put this out there for your safety, to keep you safe, and it also helps cover and protect the company that you work for as well. If you get injured and you're wearing your PPE, you should be covered. That might not always be the case, but you should be fine as far as you follow company protocols. And if you do get injured and you're not wearing your PPE or not using that properly, then the company does not have to cover you, say like with workers' comp or anything like that. So it works both ways. It's the way a company protects themselves from liability and also to keep you safe. I'm actually not sure if I'm allowed to say stuff like that, but I did anyway.
We should have turned that in our ocean class that we had to take.
Yeah. This,
What was it that we?
your ocean 10 hour you got?
Yeah, it was 10 hours.
Okay.
That is, I mean, let's call it what it is. That is safety awareness.
Yeah.
It's not really telling you specifically how to be safe, more of be aware of your surroundings, be aware of what's going on around you, and take whatever safety measures various protocols might call for. Along with that too, there's crew protective equipment. That would be things like your flashers on your truck, or you got extra lights on your truck. You have signs notifying traffic that you have, or survey work is being done in the road ahead, traffic cones, things of that nature. There's also talk of various hazards, and obviously we use some tools that can be hazardous. namely machetes probably come to mind first and foremost. I actually worked for a company, if you got a brand new machete, they would purposefully take like the top 2-3 inches and dull that. And the thought was, you can't cut yourself.
I feel like it would be the bottom that would, or like the middle that would be most likely to cut you.
Yeah, you know, I think I cut a steak with a steak knife, not a butter knife. I think a dull knife can be more dangerous sometimes, however.
Yeah.
That was their thing. They would dull the tip of the blade on purpose, just like the top 2-3 inches,
Okay.
so you couldn't cut yourself with it.
That's really funny.
I don't know. Sometimes you just gotta say, okay,
They
shake
make
your head.
square machetes.
They do, what are they, are they actually corn knives?
There's a couple different types.
Yeah, the guy that worked for us, he sharpened the machete real good. And it was just cut through everything like butter, you know? And
Yeah.
Went and cut a sapling, went straight into his shin, and dude, that thing stuck in his
Oh,
shin.
Jesus.
So there are hazards of using tools, and machetes are probably the number one thing a lot of people think of.
Popped
Yeah.
it out, but
We also use like brush axes and hand saws maybe. Maybe occasionally you can get into a chainsaw, but from my experience, that's very few and far between.
when we ran like, the outlight and stuff all the time, had to use a chainsaw to cut poles through. Or my grandpa made us, you know,
Yeah.
use a chainsaw.
Yeah, yeah.
He swore that was the easiest way, but not always.
Yeah, I would think a chainsaw and honeysuckle go very well together. Very easy to get that stuff out of your way quickly and efficiently, but.
Yeah, it depends on it.
Right, and other things too, you know, using hammer drills, you keep your eyeglasses on, your eye protection on, because you're going to hit asphalt and whatever else shooting back up at you. Don't want to poke your eye out, kid. Some other hazards we deal with too could be in nature, such as poison ivy and animals.
Ticks.
Probably animals would be one of the bigger ones. I have actually had, and I swear by this, I've had dogs come towards me looking very aggressive and barking. And if you start clapping, look excited, sound excited, like, hey, where's your stick? Where's your ball? 9 times out of 10, they turn instantly from aggressive to, oh, you wanna play? And they'll turn around and run, and I've had dogs bring a ball back, bring a stick back, bring something back. I mean, that's not gonna work all the time, but I grew up around dogs, I'm not afraid of dogs, but it's just funny how they come at you very aggressive, and if you start acting like you wanna play with them, boy, they change like they flip like a light switch, it's funny. Yeah, obviously other things in nature could be poison oak, poison ivy, things to that you gotta be careful with.
Ticks.
Ticks, oh, ticks, yes. The evil arch enemy of surveyors alongside of honeysuckle would be ticks.
Thanks. For me, anyways. Probably only me.
Other natural type of hazards could be, yeah, if you're out in the woods, you going up and down through hills, creeks, you know, slip and fall in mud, bust your butt. Walking through a field and don't see a groundhog hole or gopher hole or something, step in that, twist your ankle. Various things you just really need to be mindful of and careful of your surroundings. And of course, we don't have to really get into much about highway. I think roadways are pretty dangerous for obvious reasons. Seems like we do have more and more phone enthusiasts driving. A lot of distracted driving. Construction sites is another place you really need to be careful of, especially if there's a lot of heavy machinery moving around. If that is the case, there's like trucks moving dirt, you know, making sure you make eye contact with the operators, that they see you and they know you are there. Your high-vis vest is another thing to kind of help with that. But really keeping your head on a swivel, watching your surroundings. Safety starts with you. Talking about measurement principles. Total honesty is required. So if you make measurements and something isn't checking or something doesn't look right, stop, ask questions, verify. If you need to go talk to somebody, do so. It is so much easier to stop a project because something's not looking right, maybe on a layout job. It's a lot cheaper to hold up a job for an hour or two versus staking out a building in the wrong location. We talk about mistakes and errors as well. Per the book here, mistakes, also called blunders, are large. They occur because of carelessness, lack of understanding of the plans, lack of knowledge about measurement techniques, and lack of knowledge about measuring equipment. That is why mistakes can usually be avoided by checking, rechecking, double checking your checks, triple checking your double check. Redundancy builds confidence, always check. Errors are a little bit different there as far as they exist in every measurement we make. They also differ from mistakes in size. Where mistakes are large, errors are typically very small. They are due to human limitations or slight imperfections in the manufacture of survey instruments. Some of the human limitations can be eyesight, sense of feel, touch, or physical ability, dexterity, overall mechanical talent. So kind of the difference between mistakes and errors. Mistakes typically are due to carelessness. They can be large and costly. They can be from a lack of understanding, and a lot of times can be eliminated by checking and rechecking. Errors are always going to exist. They're typically small. They can be due to human limitations or imperfections in the equipment. A way to reduce errors are by using proper techniques, math formulas, and proper procedures. So aim for utilizing good habits, not aiming for perfection. Another thing that this chapter talks about is your accuracy versus precision. Accuracy is defined as being able to obtain the true value of measurements taken. And precision, on the other hand, would be the closeness of measurements to each other. I like to think of, and I'll just draw this real quick here, you got a bullseye. If you're like a target shooter or something like that. You take a handful of shots and you got a random grouping of your shots like this. You would say precision has to do with the tightness of the pattern. Is it accurate? No, because the bullseye would be your absolute value. If you got a bunch of shots around the bullseye, that could be more accurate because it's closer to the absolute value. However, it cannot, or possibly not be precise because of a large spread or a large, your pattern is a lot looser, a lot bigger. Accuracy, closest to value. Precision would be the tightness or grouping of your measurements. Questions? Again, I'm just kind of summarizing these chapters here. Please feel free to interact and ask questions, talk. love to have some interaction with you. And the next part of this, chapter 3, tolerances for construction layout. These can vary, and there's a table in the book, some common tolerances for construction layout. It varies by what type of project you're working on and what you're laying out. Say for example, if you're laying out a wall for a building or anchor bolts, you need to be within 1/100th of a foot. Blue tops, which I don't think are really used much anymore. Anybody know what a blue top is? Ever heard of that term? So blue top would be when you're setting grade, you're using a hub, you would set the top of the hub to the proposed elevation. So whatever that is, so the top of the hub is going to be what you're supposed to cut fill to. Hopefully fill, because it's sticking up a little bit. Fine grade, why in God's green earth does he have inches in here? That makes me cringe. Fine grade 1/4 of an inch. Why, Wes, why? So let's kind of think about this here too. Depends on what you're laying out. If you're setting, you're laying out a detention or retention basin, you're staking contours. If you're within a couple tenths on your horizontal location, chances are you're going to be good. You're going to grade probably to the nearest 1/10 of a foot as well. A tolerance that we always use, or I've used at many companies working, is if we were grading a lath, say a rough grade for the detention retention basin or something like that. If we were grading a lath, we would grade to the nearest 1/10 of a foot. If we were grading a hub that was set for an offset of a structure, we were grading to the nearest 100th. I think about this too, like, we got a lath in the ground. When you set your rod next to that, we're using a prism pole, it's got a pointy end, it's probably gonna sink a little bit, it's not gonna be true. One of the things I used to do is after I hit the hammer in the lath, set the hammer down and actually put the rod on the hammer. That way I'd have a good, at least spot to measure my cut or fill. Other things too, like you're staking out of a building. You want to stake out the corners and the offsets pretty good, within a couple hundredths. I would even say the corners, you could probably be a little more lax, maybe 5/100ths. Your chances are you're probably for a building going to put in a lath that at the actual building corner, that's going to get dug out for the foundation. We will put offsets in for things like that, and that needs to be very close, within probably 200ths. I had a crew chief yell at me one time. We were staking out sanitary. I think I've said this story before, at least some class or probably this one. We're putting a lath in at the center of the structure, and I'm trying to get him in, out, left, right, like just Nat's ass perfect. And I told him like, okay, go out like a 1/10 or something like that. And he hollers at me, he's like, it's a 4-foot manhole. It's the center of a 4-foot manhole. If I'm within a 1/10, I'm good. Just tell me I'm good. You know, kind of take into consideration. Various jobs too can also maybe have specific tolerances they need to meet. Construction layout, your tolerances are going to be different than if you're setting control. You want to try to be very tight with your tolerances. You want to try to take very good measurements in that aspect. Field note keeping practices. And I think a lot of places, when we're out in the field, we're just using a data collector, we're using a robot, we're using GPS, whatever, and running a data collector. And all the measurements that we take are being stored in a data collector. Field books are still very important. If that data in the data collector gets corrupt, How can you show what work was completed? I would say, well, I've always heard more of surveying cases going to court over boundaries versus construction. I assume that's, you could go to court over a construction layout problem. Having good hard documentation is a good resource to have in case any data, again, got corrupt. You have a good hard copy. Another important thing I would say to kind of put more focus on why you should keep a field book for yourself. All of you students here are wanting, your goal is to get a license eventually, right? Part of your pathway to getting your license has to do with experience. And you have to show progressive experience. So if you keep a field book and you keep a list of all the work you're doing and the type of work and how you did it in a field book, you have good hard copy proof evidence of your experience. Within this chapter 2, or within this section of the chapter, we talk about the layout of field books, guidelines, methods for note keeping, and keeping math checks. The layout of the field book is going to kind of vary and depend on what type of work you're doing. I'm pretty sure most everybody still uses a field book or some kind of notes when they are running level loops, transferring elevations, setting new benchmarks, things of that nature. It's still good for even doing layout or boundary work, noting what control point you're set up on, what control point you're back sighting, what points you are locating, and even providing a small sketch. Sketch doesn't have to be to scale, sketch doesn't have to be perfect, but I would recommend using at least a minimum of small straight edge to draw straight lines. This can also help in the office if people have any kind of questions about site conditions. If you have a little sketch, it can kind of help visualize a little better. Of course, let's also keep in mind here too, I know everybody's thinking with all the technology we have, it's like it's easy enough to fire up Google Earth or whatever and get a general view of the site. Still, it's kind of a good practice, and again, I would say from a liability standpoint, keeping a hard copy of the evidence of the work you completed. I'm not going to go through too much of the methods and the note-keeping math checks. Please read. Again, this is just a summary of the chapter. But in general, does anybody have any questions about note-keeping? Maybe I can kind of answer something from my past experience. Just as a future reference, in the geodetic class where we actually have a lab in person, we go out and do some various work where we set a base up and do some static observations. We do some RTK work. It's good in that case to also keep notes, know where you started your point, or where you put your base, what point you put your base on, when you started the static session, when you ended the static session, the base height, things of that nature. That's very important, very good to also keep notes of. General instrument care, talking about surveying instruments, transporting them, general instrument care and use, electronic surveying instruments, and tripods. This book is a bit dated, I'm not gonna lie. I can think of, even from my own experience out in the field, like, wow, you know, he's talking about things that we don't always use every day in the field. You know, as far as the transits, we're at minimum probably going to use a robotic total station, and you know, probably more heavily on GPS use. However, keeping everything calibrated, keeping the latest firmware updated can really help. We got to take care of this equipment. You know, that's a key thing to really take from this. This equipment is precision equipment, and it is paying your paycheck. essentially. So it is important to take good care of it, make sure it's calibrated regularly. In case of like some GPS receivers, making sure you've got firmware updated. I have had an instance where we were using a Trimble SX-10 when they first came out, and that's kind of a scanner total station combined. I went out to specifically do some scanning, and when I got out on site, the scanning portion did not work. It just completely quit. I could still do topo, which I did in lieu of the scanning that they wanted. It turned out the problem was there was a new firmware update in the total station scanner. Once that got updated, it worked like a brand new piece of equipment. So again, keeping everything nice, clean, calibrated, taking good care of it. Your tripods are another thing that are very important as well. Those can be used still to set up maybe a backside, set up your base, set up your instrument. We had found, especially with like the older wooden legs, maybe some people still have or use old wood legs, if they get wet, that wood can swell. You want to keep those like unlocked while they dry out so it doesn't cause any problems. Use and care of hand tools. So taking care of maintaining your tools, knowing them, general rules of use, general surveying equipment, instrument handling guidelines. I don't know, when I first look at this, a lot of things I think of right away is machete starts just flashing in my head. The importance of maintaining your machete, keeping it clean, don't let it sit with mud caked on it and it starts rusting. Keeping that wiped clean, keeping it sharp. Know the general rules as far as like kind of safety, as far as working with machete with people around you. I think a bad thing to do would be hold that machete out straight out and go, yell safety circle and just start swinging widely. Make sure nobody's within an area. Do not do that. And the handling guidelines, you gotta be very careful with those. I got to a point in life where I would not go into the woods without a pair of safety glasses on, whether sunglasses or safety type sunglass. I just got tired of getting sticks in the eyes. So the general handling guidelines. Be careful with the equipment you're using. Take care of it. It will take care of you. That's how you're making your paycheck, is with this equipment. Take good care of it. I guess that's probably the easiest way I think of, like, just keep that in your mind. Leveling an instrument. So general principles, there's procedure for a 4-screw leveling head, procedure for a 3-screw leveling head, and for an electronic leveling system. I would recommend when you're reading the book, if you want to kind of gloss over the 4-screw leveling head, I don't know of any modern equipment that uses that, but if you want to set up an antique transit, maybe it's good to at least have a general idea of the principles, how to do so. The procedure for the 3-screw leveling head is going to be more common. That's what we're going to see on our total stations, our levels that we use, and things along those lines. And the way I look at that and or think of that, I want to find me a better marker. Regardless what you have set up here, whether it's a level, a total station, I'm looking at these 3 screws. I'm going to line up my level bubble first, parallel to 2 of these. And we use our left thumb rule, meaning we turn both screws out at the same time or both screws in at the same time. And with that, the direction of your left thumb is the way the level bubble will move. Once you get that leveled in this direction, you would turn 90 degrees, so your level bubble is now perpendicular to this axis in line with this. Using your left thumb again, turn that one single screw, using your left thumb rule, whichever way you need the level bubble to go to, your left thumb will tell you which way it's going. I think everybody's heard that, everybody knows that, we've talked about that before in the past. No particular questions on that? Just for the fun of it though, because we're here, we'll just say real quick, if you did have a 4 screw post leveling head, you would want to line up with the 2 screws opposite of each other, get those leveled up, then turn it 90 degrees, get those 2 leveled up together, and you can kind of go back and forth a little bit and check, make sure you're doing good. Now we know. The procedure for the electronic leveling system, for those of you that may have used a robot, yes?
I was gonna ask, does the 4-screw leveling system does it have like a bubble in a circle the same way the other one does, or is it 2 straight ones?
No, typically it's one of the vial,
Really?
I guess I would say.
So is it just like at a weird angle, or is it just the one of them?
I guess remind me when we get an instrument, I almost have thought about bringing an instrument or something that's like that to show you. The 3 and 4 post leveling heads, you'll have a little bullseye bubble like we saw on the automatic level, just a little bullseye bubble on the tri-brack.
Right.
But on the instrument itself, it will have like a little vial, if you will. And that's what you're going to fine tune and use.
Sweet.
Yes, it is very sweet. Procedure for the electronic leveling system, for those of you who have used a data collector before and a robotic tow station. When you go through the initial setup and the instrument and data collector start talking to each other, typically a leveling screen will pop up and you can fine tune adjust that. That's basically what this is talking about here. So all your same principles as far as the left thumb rule and utilizing your screws would be the same. It's just now you're looking at the leveling information on a screen. Question? Comments, concerns? Clear as mud? You guys are just riveted by these amazing PowerPoints I threw together. So when you're reading through the book, it has talks about instrument setups, procedure for setup with a plumb bob, with an optical plummet, and a laser plummet. Again, I would kind of skip over the setup with a plumb bob. I don't think again, that's going to be if you're using a 4-post antique to set it up, you're going to have a plumb bob hanging off of that. I would think that has got to be very tricky. I've never done it in my life. We always had the optical plummets. We've seen those with the robots and even the older total stations. Some of the newer instruments still have a laser plummet where you push a button and all of a sudden you look down the ground and right by your target you see a little laser dot. That's pretty handy. That way you don't have to look through anything. But all the procedures still are the same. You just start looking down at a dot on the ground versus looking through an optical plumb at a target. Read up, it's fascinating. Okay, so jumping over to chapter 6, talking about total stations. There's some general information, types of total stations, basic measurements, standard practices, and preparing total station measurement. Ooh, what could all this stuff mean? So in the general section there, it talks about the advantages and disadvantages of total stations, the capabilities, and the relative precision. Let's jump over to that book real quick, because I think there was some pretty interesting things to maybe talk a little bit more in depth about. What can anybody got some ideas? Tell me what are some advantages of a total station? Not everybody wants one at a time, one at a time. Yes, Adrian?
You don't need to lug a whole bunch of different surveying setups out there.
No, you do not. One single instrument, nice, quick and easy. When you shoot a distance with the total station, you're getting an instant horizontal distance. No computing there.
They're affected by buildings and trees a lot more.
They're not affected by trees and
They
buildings.
are, a lot more at total station.
So,
Just the auto tracker one, right? The one with the computer in it that can see the IR target.
yeah, that would be a disadvantage. We'll jump over to the disadvantages here for. But they're generally kind of easy to learn. Everybody's fairly tech savvy, right?
Yeah.
You kind of pick up a data collector and start figuring things out pretty easily. You have a computer right there in your hand, right there for ease of calculations. And again, like kind of mentioned before, it's kind of like an electronic field book. It's recording all your measurements, all your data. Some disadvantages of the total station can be things like Gavin mentioned. You need intervisibility between the points, so that can be affected if there are things in the way, trees, buildings, construction equipment, things of that nature. Robotic total stations specifically can be very expensive depending on the brand as well. Batteries could be a potential problem. Making sure you have enough charge in your batteries. Somebody did not, forget to plug them in. That can be another thing. And weather conditions. A lot of these manufacturers will say that they're water resistant. I would keep in mind that is very different than waterproof. Water resistant, it can take some, but not a lot. I think I've heard some people say, oh yeah, this is waterproof. I say, be careful. It gets very expensive if you break it because it was out in the rain too long. Some of the general capabilities of a total station, I mean, they can do pretty much everything and anything we need. Measuring horizontal angles, vertical angles, shooting slope distances, shooting elevations, shooting horizontal distances. A lot of capabilities to these things. I do believe personally, sometimes it can be quicker to set up a total station than use GPS. From my experience of particularly using robotic total stations and using topo, you can get instantaneous positions. As soon as you set the rod down and have it level, you can store that location. A lot of times from the GPS receivers that I've used, you set the rod down, get it level, you go store it, it counts down 3-5 seconds. So there can be a little bit of a quicker storing of information. I would always prefer to set up a total station if we had to do any kind of topo in the road, because I don't want to be out in the road any longer than I had to. Get out there, set it, store, I'm out of the way. I didn't have to sit there and store, wait 3-5 seconds, and then store the observation. So in some instances, it can definitely be, I think, a little quicker. It all depends on what you're doing. Relative precision. This is kind of a nice thing to keep in mind, know about. Per the book here, the precision of these total stations usually found to be plus or minus 1/100 of a foot, or 3 millimeters for any distance measured. So a distance of 10 feet displayed on the total station will be 9.98 to 10.02. A lot of those too will have the relative precisions listed as maybe, you know, 100th, 200th plus 50 parts per million, plus 100 parts per million. So keeping that in mind, that's that first part is a constant, the 1, 2, 300ths, whatever that is. The parts per million is scalar. And what that means is that can be dependent on the length of the line you are measuring. So you take your, whatever your parts per million is, if it's 50, divide 50 by 1 million, multiply that by the length of your line, you get some decimal place way far out, add that to your 100th or your constant part, and that's going to give you your relative precisions. Not so easy for me to say. Most every instrument you have should have some kind of a certificate associated with it that gives you these numbers. It's good to kind of know and be aware of the capabilities. You know, that's one thing I think people need to be mindful of, is those really control how good you can measure. I don't care if my data collector or whatever display is 5 decimal places out. What are the capabilities of the instrument itself? That's what really is going to be controlling how good you can measure. In this too, we're also talking about types of total stations. Total, full-featured, reflectorless, and robotic. I would recommend probably just focusing probably more on the robotic total stations, considering that's most likely what you're using more of nowadays. A lot of these robotic total stations can shoot reflectorless, meaning you don't have to point it to a prism to get a distance measured. The full featured and basic, I guess I could open up the book and see what exactly is the difference between a basic and full featured. However, I would say the main difference is probably going to be that you have to have somebody standing behind them compared to a robotic. You actually have to have somebody manually turn the angle, manually push the button to shoot the distance or measure the elevation. They still turn horizontal and vertical angles, do it very well. They still can shoot elevations. They still can measure distances, horizontal and slope. It's just you need somebody behind it to manually operate it. Just because we have new technology like robotic total stations doesn't mean the older total stations that are not robotic are junk. They are still good. They can still turn good equipment, provided they've been taken care of for their whole life. Another part of chapter 6 here is in basic measurements, standard practice. Preparing to use the total station, learning how to use the station display. I add a data collector to that because there's not really a lot of robotic total stations don't have displays on them. Checking the calibration, configuring the prism constants. Having good solid setups, making sure you're set up exactly over the point, leveled over the point, ensure visibility between your points, and atmospheric ppm corrections. The atmospheric ppm corrections, so in the olden days when we measured distances strictly with steel tape, 100-foot steel tape, those were designed with a specific sag correction as well as a temperature correction. The temperature correction had to do with the coefficient of steel, the expansion. These total stations are shooting electromagnetic energy out and back from the instrument to the prism and back. So I think we probably learned if we've taken a physics class how different sources of energy travel through different mediums and it changes. So things like your temperature, your pressure, your humidity can affect the way your total station is shooting distances. That's something to really be mindful of, particularly in the spring and the fall when it's like maybe starts out cold in the morning and gets really warm in the afternoon. To change those atmospheric corrections, maybe at least once in the morning, once in the afternoon, or maybe a couple times depending on how quickly the weather changes. Yeah, I think setting up over the point, being level, I think we all did that one pretty well. So he really takes a deep dive, goes into leveling pretty good. There's an introduction, talks about standard practices, field notes for leveling, differential, profile, cross-section, grid leveling, transferring elevations, applied leveling, and setting grade. Does anybody have any questions about any of this so far? Again, I'm just kind of glossing over, summarizing what I hope you all will be reading in your books.
Well, I'm not sure if it has, like, I've used the S5 and stuff like that.
Mhm.
I never, like, was told or I've never done, like, an actual barometric pressure reading. It just automatically calculates that. Does it have, like, a measure in it, or is it, just assuming based on the temperature or something, or is it just not that important when you're doing short distances?
I would say it would be good practice to watch that and change it accordingly, regardless if you're shooting long, short distances. Yeah, when you are using a Trimble S5 robotic till station, you got a data collector hooked up to it. Once they start talking and you get it all fine leveled, it does ask about like the PPM. I don't know if you saw that. Remember seeing that screen? So you can change the temperature, you can change the pressure, and that will change the PPM automatically, calculate that for you. The easiest thing to do would be, check your weather app. What is it, where I'm at, what's the pressure? Punch that in accordingly. It can affect you. I just think a good practice, regardless of what I'm doing, if I'm just rough staking something or it don't matter, I'm just shooting something real quick. Just good practice, good habit to always do that, regardless. The Trimble specifically, you can punch in a specific temperature and a pressure, and it will calculate the PPM. So back in the day, before that, used to have a chart where we look at, okay, what's the pressure, on one axis, what's the temperature on another axis, intersect them, and okay, this is our PPM that we need to maybe punch into the instrument. It wouldn't do the calculation for you automatically. So the introduction to this chapter talks about differential leveling basics, the theory of differential leveling, quick description of the leveling process, leveling instruments, and level rods. Is there anything particular I want to get out of that? A handful of you have done some leveling in the past, right? That's your job or something, maybe. Set a benchmark, pull off a benchmark. A lot of the stuff in this book, we talk specifically about setting grade and things like that. There are occasions today where some people still will grade their layout with an automatic level versus using a total station versus using GPS. The best example I can think of is where grade is critical, meaning you have some sanitary sewer that runs at the minimum percent. And typically, from what I've seen, at least around here in Southwest Ohio, that can range to about 0.5% is the minimum for sanitary. So they're very critical to make sure that they hit that and they want good elevations, and leveling is still considered to be best method for accurate elevation transfer. Yeah, if you're in a hilly area and fall is not an issue for sewer, yeah, we're gonna shoot elevations with the gun all day long, the instrument. So for those of you who have done differential leveling, how many people have not done any differential leveling at all? Ever, never in their life? Anybody? So you understand what you're doing is setting up an automatic level in between your benchmark and the point that you want to establish a point on, or an elevation on. Get this randomly set up in the middle, you take a rod that's going to be set on the benchmark. You're going to read the rod elevation. You're starting off with a known elevation. You add that the rod reading to your elevation, and you are establishing an HI, which would be the horizontal plane at the line of sight. You take that, you turn to your foresight, set the rod down on the point you want to put an elevation on, read the rod height, and you subtract that rod height, and that will give you the elevation of your foresight point. That, in a nutshell, real quick, is differential leveling. We need to go more, or can you guys read about the theory and description of the process? Standards and practices, setting up, focusing, rod use, and field practices. So when you are doing differential leveling, when you set up your level, you want to try to set up the best you can in the middle between your benchmark and the foresight point you're going to. Doesn't have to be exact, but you want to try to keep the legs of that foresight and backsight to be pretty balanced. That's where stadia can come in handy. You can shoot a distance and get a distance in near split using the stadia lines in your level. As your rodman's coming up to you, you can say, hey, that was so far feet away, they can pace to the next point, see how close we are. So setting up, making sure you're good and level. The focusing has to talk about parallax. We all familiar with parallax? That's the concept of your crosshairs and the focus of the actual, what you're looking at aren't lined up very well, and it looks like maybe you have multiple crosshairs, or they kind of bouncing on you. So one of the key things with that to eliminate parallax when setting up a level is you want to focus on the crosshairs and get those focused on your eye first. Get that nice, crisp, dark, as bold as you possibly can. Then keeping your eye focused on the crosshairs once you get those nice and dark. Then focus on the whole big picture. Bring everything else into focus. That will help eliminate parallax. Talk about rod use. So the person who is running the rod, a couple things I try to stress when we look at this and run level loops. When you hold the rod, don't hold it like this. My experience, wherever the rodman's holding onto the rod like this, where their hands are, always seems to fall exactly where I need to read. And then, hey, move your hands. A good practice would be kind of pinching it on the side, keeping the front always clear to the level. Another thing we have are those little hand levels that we can put up against the level rod, and we can kind of keep this plumb and steady. If you do not have that, what a proper technique would be called rocking the rod, where you would rock it forward and backwards. Slow and easy, you don't want to go too crazy, too fast. So the person looking through the instrument, looking through the level, is going to watch this rod rock. And as they're looking at this, as you rock forward, they're going to read bigger numbers. When it gets back and it's plumb, they're going to read a low number. And as you rock backwards, it's going to go high again. So the person, if you are doing some rod rocking, the person who's looking through the level is going to be reading, watching that crosshair, and look for the lowest number. That is what you're looking for. That would be the same as if you were holding it plumb. Does that make sense? So you'd always want to look through, if your person's rocking the rod, you always would look for the lowest reading of those crosshairs. It's going to go up, it's going to come down, it's going to go up, down, up. I'm exaggerating a little bit. Imagine I was doing that perfectly, matching every time. Some other instances too with the rod use that you want to be mindful of. If you are running the rod, how you set that down on the ground. You know, are you on a construction site that's muddy? You'd want to be very careful with the bottom of the rod. Once you get a rod reading, then you go move over and you set it down and you get a clump of mud. Now you just added something to the bottom of it that wasn't there before. You want to make sure that stays clean. Preferably just keep it off of the ground. I was told a long time ago, if you set it down before you even got started, if you took your backside with that clump on it, keep that clump of mud on it when you go to your foresight. I would just say best practice, recommend, just walk with it, keep the rod bottom off the ground to keep it clean. Even when you get to maybe your foresight point, you're waiting, put the rod down on the toe of your boot. Just don't put it down the ground so you don't pick up any extra mud or anything else on the bottom. Now, something I used to love to do with my old crew chief, when we would run our level loop, we start at our benchmark, we'd go set our points, elevations on all our points, and we tie back into our benchmark. When we come back in for that tie-in benchmark, I'd always take the rod and flip it upside down on him. Then he would look at that, and then all of a sudden I'd see him stand up and look at me, and I'd act like I was laughing. It was a fun joke. We used to have fun with each other all the time like that. But no, that's just a way to mess with your instrument operator or level operator. Any kind of questions on this kind of basics of rod use and things to that nature? So there's a section on field notes for leveling, recording level data, sample notes for a typical level loop, the arithmetic trick, and rules related to field book use. Yeah, it might be something good to kind of touch on a little bit more here. I know some of us do have familiarity with that. Let's just, oh boy, that looks terrible. Is that a little more readable?
Yeah.
Okay, so what I'm looking at here is page 718 in your book. This is an example of level notes. So what he has here is the description over on this side of what your point is. Your back sight, your HI, your foresight, side shots if you are doing profile leveling, and the elevation. And me personally, when I was doing this, I always had the description over here to the right side of the elevation. That's just me. So if I was starting at my benchmark, I'd write benchmark, concrete monument, or whatever it may be. And I'd have the elevation right next to it. Either way, the math is still going to stay the same. We recall when we take a backsite reading off of an elevation, we are going to add that rod reading and get our HI. Now, something I used to do all the time, is when I was getting this set up in my field book, is in my backsite, I'd write a plus sign, and at my foresight, I would write a minus sign. Just as a friendly reminder to myself, start off with my elevation, I would add my backsite rod height to get my HI. That's when we go to the foresight, I'm gonna write that foresight height down, I'm gonna subtract that from my HI, and that's gonna get my elevation. And just proceed, follow the same thing. So you have an elevation, add your next backside height, that's going to be your HI, subtract your foresight height, the following elevation. When you run a loop, you start at a benchmark, you end at a benchmark, the same point. That's where you can calculate your misclosure on that. So whatever the difference is between the starting and ending is your misclosure. Another way to check this, and this is what personally I did a lot. I wouldn't go through and do the math of calculating the HI and the elevations until the end. What I would first do is I would take all of my back sites, add them up. I get a number. Then I come over here and I would add up all of my foresights and I get a number. The difference between the back sights and some of the back sights and the sum of the foresights is your misclosure. That'll tell you right away, am I within my tolerances? Do I need to rerun this? Am I good? And usually then what I would do after I got that, I would go through and do the math. I would start off with my elevation, calculate my HI, calculate my next elevation, so on and so forth. And I use that to make sure, okay, if I came up with some kind of a misclosure by adding up my backsights and foresights, I'd go through the math, calculate the elevations, and verify that difference should be the same. Does that make sense? So that would have to do with the arithmetic check. The procedures, we kind of did go over that. There's just a little bit more in depth if you want to see that. Profile leveling. What's the difference between differential leveling and profile leveling? Does anybody know that?
Well, you're getting like this horizontal, like a side view map of the elevation changes, whereas if it's differential, it's like you're just trying to put a elevation on a point at the end.
Yeah. So yes, when you're doing a profile leveling, think of like a road profile that you've probably seen. You're getting the elevations along an alignment. I kind of think of this and kind of compare it to a traverse, a horizontal traverse. When you're doing a horizontal traverse, you're set up on a point, you're backsighting a point, you're foresighting your next control point. Then you move up to that next control point, you backsight where you came from, foresight to your next one. Differential leveling is kind of the vertical equivalent to a horizontal traverse, where you're moving between points. You start at one point, you go around, tie into another. If you're doing a traverse and doing a boundary survey, you're running from control point to control point, running that closed loop. And if you find monumentation at the property corners, you're doing a side shot, right? So you're just turning an extra angle and measuring another distance over to this property corner. But it's not part of the actual loop, because you're not going to go occupy that and move on around. You're going to stay on your control points. You're just going to shoot and get an extra measurement over to this monument. That's where the profile leveling comes in. Is typically that's going to be along an alignment. You're going to be running your differential leveling, so you're going to go from control point to control point to control point. However, you're going to take side shots, so you'll get extra foresight readings, then move over to your next foresight, shoot your foresight, move over, pull off of your now back sight, get some side shots, if you will, along that alignment, and then go to your foresight, your next control point, set your elevation, and move along. So they're not part of the actual loop, like a side shot and horizontal traverse is not part of the loop. There are no real checks other than making multiple angle and distance measurements. Kind of same thing for the profile leveling. That's kind of floating out there. You have no real check to that. But that's profile leveling is where you're getting, I like to say, side shots. You're going to shoot multiple things and then move to your next control point. Does that make sense? Is that kind of clear-ish? Cross-section leveling. Everybody familiar with the term cross-section? What a cross-section means? So, I don't know if this might be better or worse. Say you have an alignment, a center line of a road. Imagine everything's perfectly straight, smooth, symmetrical, looks wonderful. So you have a roadway. Imagine that looks like beautiful. If you were to take a slice of that, we're looking at this from what's called a plan view, as if you were above it, maybe in an airplane looking straight down. This would be called a plan view. If we were to take a slice along this and look at it sideways along the alignment, so maybe vertically this thing's doing something like this, that would be a profile view. We're looking along the alignment at the vertical component. I don't know how to really draw that. A cross-section view would be perpendicular to that, so that would be like taking a slice this way and looking so you may have the road has a crown, and then from here maybe it goes down to a ditch and then ties into existing or something like that. This would be your cross-section view. So in this case of doing cross-section leveling, you would be hitting like maybe your top of bank, toe of slope, edge of pavement, center line, edge of pavement, or center ditch, top of bank, whatever, so on and so forth. That makes sense? I hope that's visible in my camera. I myself have not really ever done any cross sections by leveling like that. Typically that's been done with the total station or the GPS and doing general topo. And from that, once a surface is built, then they would cut their cross sections to look at things. Talking about grid leveling. So this would be as if you had an area, say like this classroom for example, and you would lay out a grid and get an elevation every 2 feet, 5 feet. If you look at like the tile on the floor, those are like probably 1 foot tile, I'm guessing. Think of that as your grid, and you were going to get an elevation at every single corner. Now, whatever the spacing of your grid may be, 1 foot, 10 feet, 50 feet, whatever. That would be laying out a grid and getting an elevation at each point on that grid. I have actually done this once before. Over at Kenwood Mall, there was a Microsoft store. I don't think it's in there anymore. However, they were going to build kind of a false floor, build it up off of the existing subfloor, so they could run all their cables underneath and then have them come up to all the tables and stuff in the middle, kind of like the Apple Store, if you've ever been in there. So we actually laid out a grid through this thing. I think it might have been, it was probably less than 5 feet, 2 feet maybe. And then we actually took a level and we got elevations there so they could see the flatness of the floor and how much they needed to build in various places to build that fake floor up. So it can happen. You probably won't come across this too terribly much. Read up, chapter 7 starts at page 39. So we talk about transferring elevations and the equipment. What we're most likely going to be using would be an automatic level. If we're talking about leveling here in chapter 7. The procedure for transferring elevations, again, we kind of go back to like the differential. And the calculations, we looked at that as far as like setting up the field notes, how you would start off with your benchmark, add your back sight, stay with your HI, subtract your foresight, there's your new elevation. And the field notes, we also kind of looked at that already as well. Applied leveling would kind of come back to what you're applying leveling to. Setting benchmarks, doing three-wire leveling, and bucking in. I'm not gonna lie. Looking through the book, when I saw bucking in, I was like, what the hell is that? I never heard of that before in my life. Setting benchmarks, kind of comes back to the differential leveling. Three-wire leveling is used when you really need to be a little more precise. It's just kind of another way of checking. So when you look through your automatic level, you should see a vertical crosshair, a horizontal crosshair, and then you will see two small lines above and below the horizontal. A small line that's going horizontal and another one. They are equally spaced from this. These are the what we call stadia lines, and this is what we use when we measured our distance. For three-wire leveling, what you do is you read the rod and record this rod reading at the top line. You read and record at the center and the same thing at the bottom. What you should do is take an average of those, and it should pretty much be the same thing as this center. So it's just kind of a way of checking. Likewise, you can take your top rod reading, your bottom rod reading, take that difference, multiply it by 100, and you have distance to the nearest foot, stadia. I want to pull this back up again. I did look at this, like, what the heck is bucking in? 740.
Hey Chris,
Yes.
please don't hate me. I
I
think I'm
don't.
getting sick.
Don't get sick.
No, like
Not feeling well?
I'm lazy.
Mm.
I don't.
Well, hey.
Do we have a nurse up here?
No, I'm just gonna go home.
Yeah, yeah,
Because
you need to
if
go to
this
the
is
nurse's
what
office.
No, this is what I think it is. I caught a stomach flu from Beaker.
Oh, that stomach bug seems to be going around. Well, do me a favor and don't share it with anybody. Get out of here.
Literally trying not to. Like as soon as I started feeling bad, let me know about homework.
Get feeling better.
I'll try not to.
So in the book, he talks about bucking in elevation. And this is kind of This could be happening on job sites, perhaps like inside of a building, continuing construction inside of a building where you're saying that a level must be set up the same day, in the same way, same spot, day after day, and set it up at the same HI. What this does is this kind of quick, once you set your benchmark, you set some reference marks. You set your level up so you read those marks, you're set the same height. That way it's very easy to keep continuing turning and transferring elevations around. That's kind of new to me. I guess in a way I've always just kind of set benchmarks where we set up a level. But then again, I wasn't at a job continuing their day after day after day after day throughout the continuation of the construction of a building like this. We would set up, maybe mark a spot on the wall that would be 4 feet above finished floor elevation, whatever that may be. And everybody would kind of set their levels up and come off of that, do their own leveling. Good to know. Setting grade, talking about standard practices and procedure for setting grade. I would say that in general, if you are doing any kind of layout, majority of the time you are going to set a grade on that, and what that means by setting a grade would be marking to a proposed elevation. So we're building a new structure, we're building a new something. It needs to be at a specific new elevation. Setting grade would be providing a cut or fill for the contractors to get to that desired proposed elevation. Make sense? Okay. So construction surveying layout, chapter 9, GPS field procedures. There's an introduction and standard practices. Again, this is where I'm going to kind of reiterate, a lot of the technology and things have changed since this book was published in the 3rd edition. General practices are still good to follow. General practices should still generally hold true, regardless as technology changes. So general job site applications and which GPS to use. That kind of confuzzled me a little bit when I saw that. I think probably you guys have used your GNSS receivers to do a lot of your surveying work nowadays. It does have its special applications where it can be very beneficial, and it also still does have its limitations. The technology is getting a lot better. So a big issue with using GPS on construction sites can be where you get multipath. And multipath is where the satellite signal comes down, it bounces off of a tree, it bounces off a building. Chain link fences also like to kind of mess with that stuff and come back to the receiver from a completely different angle than what the receiver should be receiving that signal at. That was kind of a little confusing. I did have an instance where I was on a job site and I was staking, there was a, what was it? A food processing place was putting an addition on, and they had some prefab concrete walls that they stood up. I was in there after they had the walls up. I was on the outside staking a combination of sidewalk and curb for them, right up against this wall. I had my instruments set up kind of out towards the front of the site. It wasn't very far from the curb, so I had a traverse point up there. And I'm shooting in up against the side of this building, putting my grade stakes in. And there's a guy on a dozer with his machine control, and he's telling me my grades are way off. Well, he actually goes and complains to the site super that surveyor don't know what he's doing, he's putting bad grades in. And, I'm pretty confident that running GPS up against a concrete wall like this, and this concrete wall was, I don't know, 20, 30 feet tall. It was big. I'm pretty confident that the GPS was not getting very good signal, and there was some issues there with his thing. So the site super got me, said, hey, need you to check all these grades. You know, they're saying that your grades are way off. And I just looked at him and said, okay, so you realize that the GPS is up against a concrete wall. That is not an ideal situation for that to be used. I'm setting all this with a total station. I'm turning angles and measuring distances. Do you think the instrument is way off compared to the GPS up against a concrete wall? And he kind of looked at the guy on the dozer, and he looked at me, and he looked over again, and he said, okay, we're good here. You're fine. I was like, I can check this stuff if you want, but I'm pretty confident with the methods that I'm using here that I'm getting good elevations and things, but we can check.
I ran into a similar issue with I wasn't staking anything, but it was just like getting topo points.
Mm-hmm.
Down in northern Kentucky, right near like a levee wall. It's just similar. It was actually metal though, a metal like 30-foot wall
Wow.
with concrete behind it. So I had like an R12i though, so I was able to like
Kind of get
tilt
away
it.
a little bit with R12i.
I think it was decently accurate, but who knows?
Yeah, that IMU tilt sensor is pretty nice on those new GPS receivers, not gonna lie. You have to be very careful, and you have to have a way to verify your information. How good is it? How do you know? How can you check it? Now, I am fairly comfortable with, I was reading, was it the Navstar GPS? It was published by the Army Corps of Engineers, and it's about the GPS constellation specific. That's one of the things I try to, I don't know, kind of a nerdy little technicality that kind of drives me crazy when people say GPS. Technically, it's GNSS. GPS is the United States constellation of satellites. GNSS is the over-encompassing all the satellites, regardless if it's Russia's, Europe's, China's, Japanese, whatever. But either way. So these satellites, all these satellites, we're broadcasting signals with like an L1 and L2 band signal. They had all the codes and everything in it to help figure your positioning. Those were broadcast at a very low power. I don't know the exact date of when the L5 signal was introduced, but newer satellites are also doing the L1, L2 signal plus an L5. And the way I understand it is they are broadcasting that at a much higher power than the L1, L2. And that is supposed to help mitigate and help with the situation of multipath. It's got a stronger beam, it's less likely to bounce off of things and come back into your receiver. And that's probably a lot higher math than I completely comprehend myself. Again, you kind of just need to be aware of your surroundings. You need to be aware of, is this a good application for what I'm using it for? Things to that nature. Another thing we kind of talked about a little bit in this chapter here is GPS project planning, equipment care, refer to the owner's manual, logging sheets, using data and changing technology. There is project planning software. I can think of Trimble specifically, where you can punch in a time and date and location of your site, and it will give you a forecast, if you will, of where satellites should be, what satellites are operating in good health. Are there any satellites that may be turned off or have some scheduled maintenance? Maybe they're updating firmware, I don't know. But either way, you can see what kind of coverage you will have. Because PDOP, HDOP, all the DOPs are very important to be aware of. where your satellites are, if you have good satellite geometry or not. Project planning is very important. Also, another part of that I would say is space weather. You can go to the NOAA's website. I don't know it right off the top of my head, but I have a bookmark where you can look, and they have what the space weather's going on. So the sun is constantly in flux and churning and burning and spitting out solar flares and things of that nature. There is wind and radiation going through space that affects the Earth, that affects the magnetic field around the Earth. When the magnetic field is kind of in flux, I believe it's probably not the right definition, but that's where the northern lights kind of come from, is the changing of the magnetic field. Or the amount of radiation bombarding the magnetic field, something like that.
It's like charged particles hitting the magnetic.
Yes, parts and particles, things like that. So there can be enough times where the sun's radiation and space weather can have effects on power, GPS signals, and things of that nature. That's a good thing to also plan for and look to see, is this going to affect us? Some equipment care, I would also say that would come into play with like firmware. You know, do you have the latest firmware? Is there some new firmware updates that need to be inserted? I've also seen that too in the past, where I'm working with GPS and looking at like using older Trimble R8, R6 receivers. It's like, man, this thing was working really good yesterday, and now all of a sudden it kind of seems like it's taking forever to initialize. It's just not, it's just acting goofy. Take it to the Trimble rep at the time, and he's like, oh yeah, there's a new firmware update. Update the firmware and go out, and it was like, man, this thing's working like brand new again. Works great. So that's kind of something else. So depending on who your manufacturer is, a lot of firmware updates aren't pushed out regularly, but that can have an effect. GPS recording log sheets. Now, if you're depending on the type of project and what kind of control you're establishing, there is various municipalities or government agencies may have various log sheets where they want you to record every single bit of information about the time you are spending observing a control point, maybe to establish a control point. Things to what type of receiver you're using, obviously like the rod height or base height, the time you start, the time you end, all kinds of different things. I think of ODOT specifically when you're establishing control for an ODOT project. They have what they call a master control sheet, which is an Excel spreadsheet, and you can punch data in and it will give you if everything's within tolerable tolerances. But even if you're maybe establishing control for like a county or something like that, you have to have log sheets and things, depending on the county, depending on where you are. Yeah, using GPS technology and changing data, changing technology. It is changing, it seems like faster and faster every single day, every single week. All right, guys, well, that was all of our reading chapters in a nutshell. Just kind of a quick summary. Please read and look for an announcement. We'll have a lab on Thursday. It's just going to be kind of dependent on what the weather is and what we're going to do. So I will still see you here on Thursday in room 132 for lab. However, we may or may not be going outside. All right, that's about all I got for today. Thank you.